Hello people and welcome back to Maybe Ismail. In this session, we will be continuing with proving trigonometric identities. Now, if you haven't watched the first video, I would recommend to go and watch that episode first. Only then you can continue with this one, because in that we have discussed the algebraic identities and the trigonometric identities. We did around 16 questions and now we'll be continuing with the 17th question. Okay, so let us directly get into the questions. Now, this thing says I have to prove that tan square A minus tan square B is equal to sin square A minus sin square B upon cos square A into cos square B. So the first step is to decide where to start from. So I'll be obviously starting from my right hand side because the right hand side looks bigger to me. Okay, just one moment. Okay, so the right hand side is sin square A minus sin square B, and the denominator is cos square A times cos square B. I can set the denominator with both the terms in the numerator. So it becomes sin square A upon cos square A times cos square B minus sin square B upon cos square A times cos square B. Now if we know that sin upon cos is actually tan, which means we can write sin square upon cos square as tan in both the things. Okay, so this sin square A upon cos square A and this sin square B upon cos square B can actually be written as tan. So this thing now becomes tan square A upon cos square B minus this thing would become tan square B upon cos square A. Okay, now I can see that whatever is required in my answer, which is tan square A minus tan square B, I've already gotten that. The only thing is the denominators which are really messing up with me. What I would do is I would convert the cos into sec and bring it up. So this becomes tan square A into sec square B minus tan square B into sec square A. Now we all know that sec square A is 1 plus tan square A. Like I have the formula which says sec square theta is 1 plus tan square theta. So the sec square B can be written as 1 plus tan square B. So this would be tan square A times 1 plus tan square B minus tan square B is as it is. The sec square A can be written as 1 plus tan square A. I would open up the bracket, so tan square A times 1 is just tan square A plus tan square A times tan square B. So tan square A times tan square B. Now this negative tan square B again goes with both the terms inside the bracket. So it would be tan square B and then minus tan square A times tan square B. I can cancel out the tan square A, tan square B and negative tan square A, tan square B, and I'm finally left with tan square A minus tan square B, and that is exactly what is my LHS. Okay, next question. Now this one says prove that sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta is equal to tan theta. Obviously we'll be starting with the left hand side. So the left hand side is sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta. Now the first step is done. The second step is, do I need to can I see any trigonometric identities or algebraic identities? There are surely powers over here, but I cannot see any identities. So is there any fractions? No, there are no fractions. Can I convert anything to sine and cos? No, I can't do. Like everything is like null and void over here. All the 5 rules which we discussed. Okay. So what do? I can factor out a sine from the numerator and I can factor out a cos from the denominator. So this becomes sine theta times 1 minus 2 sine square theta. In the denominator, I can factor out a cos theta. So it would be 2 cos square theta minus the 1. Now, we all know that sine square theta plus cos square theta is equal to 1. Again over here, I can see in the numerator and the denominator there is a 1. Instead of 1, I'll be writing sine square theta plus cos square theta, and let's see what happens. The first thing is that over here, this sine theta upon cos theta can actually be written as tan theta. So that is exactly what is required in the answer. But I need to now get rid of these two brackets. Okay. Now, if you know the half angle formulas, if you are maybe in grade 11th or 12th, you surely know the half angle formulas and you can directly like cancel out these two brackets. If not, then this is what is supposed to be done. Instead of 1, I'll write sine square theta plus cos square theta minus the 2 sine square theta. And my denominator would be 2 cos square theta minus, instead of 1 I'll write sine square theta plus cos square theta. Now the really important thing is to put up a bracket over here because that is a minus sign. So the minus sign shows effects inside with both the terms. So this would be tan theta, and then this is sine square theta minus the 2 sine square theta would be negative sine square theta. So this is cos square theta minus sine square theta, and the denominator would be 2 cos square theta minus sine square theta minus cos square theta. So that would now become tan theta into cos square theta minus sine square theta, and the denominator is 2 cos square theta minus the last term which is the cos square theta would just become cos square theta minus I have a sine square theta. See, the numerator and denominator exactly is the same thing. I can cancel it out and my final answer would just be tan theta. Okay, next question. This one says prove that cos A upon 1 minus sin A is equal to sec A plus tan A. Now, I would start with the left hand side because that looks slightly bigger to me. So this would be cos A upon 1 minus sin A. Okay. Now, all the rules are just gonna fail over here. We do not have any powers, so no algebraic identities, no trigonometric identities. There is only one fraction, so we can't simplify any fractions. Everything is already in terms of sines and cos. I can't even factor out something the way I did in the previous question. So what do? This is one of those kind of question where you rationalize the thing, okay? So I'll have to multiply it with the conjugate of the denominator. So 1 minus sin A's conjugate would be 1 plus sin A. So I multiply and divide by 1 plus sin A. Now my numerator would become cos A times 1 plus sin A. I will not open up the bracket. But my denominator would be 1 minus sin A into 1 plus sin A, which looks like A minus B into A plus B, which is actually A square minus B square. So it would be 1 square minus sin square A. Now I can see that this is 1 minus sin square, and we all know 1 minus sin square is cos square, that is by manipulating the identities. Okay, so this would be cos A times 1 plus sin A, and the denominator now becomes cos square A. I can get rid of one of the cos from the numerator and one of them from the denominator, and I'm left with 1 plus sin A upon cos A. Okay, I would distribute the denominator, so it becomes 1 upon cos A plus sin A upon cos A. Now we all know 1 upon cos is sec, so I'll write it as sec A, and sin A upon cos A is tan A, and that is exactly what my right hand side is. Next question. So this one says prove that sin A times tan A upon 1 minus cos A is equal to 1 plus sec A. Obviously we'll be starting with the left hand side. Okay, so my left hand side is sin A times tan A upon 1 minus cos A. We have no powers, so no trigonometric identities, no algebraic identities. We only have one fraction, so we don't have multiple fractions to cross multiply. The last step is to convert everything to sine and cos. So I'll convert the tan to sine upon cos. So this is sin A. The tan A can be written as sin A upon cos A, and I already have 1 minus cos A in the denominator, so I'll write it over here, 1 minus cos A. Okay, now in the numerator, sin A times sin A just becomes sin square A, and the denominator, they just get multiplied. I won't multiply it, I'll just keep it as it is. So 1 minus cos A into cos A. Okay, now we all know that sin square theta plus cos square theta is equal to 1. If I send the cos square to the other side, so it becomes 1 minus cos square. So instead of sin square, I can write 1 minus cos square. So it becomes 1 minus cos square A, and the denominator stays the way it is, 1 minus cos A times cos A. Now the numerator, this is actually 1 square minus cos square, which is difference of squares. So A square minus B square is A plus B into A minus B. So it would be 1 plus cos A into 1 minus cos A, and the denominator is 1 minus cos A into cos A. I can get rid of the 1 minus cos A from the numerator and the denominator, and finally I am left with 1 plus cos A upon cos A. The denominator gets distributed, so it becomes 1 upon cos A plus cos A upon cos A. Cos A's can get cancelled out. So cos A upon cos A is just 1 and 1 upon cos A is sec A, and that is what my right hand side is. Next question. This one says prove that 1 plus cot A minus cosec A times 1 plus tan A plus sec A is equal to 2. We'll obviously start with the left hand side. Okay. So this is 1 plus cot A minus cosec A times 1 plus tan A plus sec A. Okay, the first step, no powers, so no trigonometric or algebraic identities. Second step, the third step is basically fractions. I don't have any fractions. The last step, convert everything to sine and cos. So this becomes 1 plus, the cot A can be written as cos A upon sine A minus, the cosec A can be written as 1 upon sine A. Okay, in the second bracket, 1 as it is. Tan A can be written as sine A upon cos A, and sec A can be written as 1 upon cos A. Now, you all should know one simple rule, that anything upon the same thing is equal to 1. Okay, that is an interesting thing. You divide anything by the thing itself, the answer is always equal to 1. That is exactly what I'm going to do with these two ones in the brackets. Okay, so in the first bracket, I'll write the 1 as sine A upon sine A. Everything else remains as it is. So it is cos A upon sine A minus 1 upon sine A. Why would I do this? Why would I divide it by like sine? Why would I write the 1 as sine A upon sine A? So that the denominator becomes same of all the fractions in the bracket. So it becomes a like fraction. Okay, which means I can combine them. And in the second bracket, I'll write it as cos A upon cos A plus sine A upon cos A plus 1 upon cos A. Okay, I can combine all of them, and this now becomes sine A plus cos A minus 1, and in the denominator I can just write 1 sine A times cos A plus sine A plus 1 can actually be written as sine A plus cos A plus 1, and in the denominator I'll just be left with 1 of the cos A. Okay. Now, if you see very closely, this is actually sine A plus cos A. This thing can be considered as one term in both the things. So, something minus something into something plus something. So, it is A plus B into A minus B, which is A square minus B square. So, this thing can be written as sine A plus cos A the whole square. So, sine A plus cos A the whole square minus 1 square. A plus B into A minus B is A square minus B square. And the denominators also get multiplied, so sine A times cos A. Over here, I can use the identity which is A plus B the whole square, which is A square plus 2AB plus B square. So sine square A plus 2 sine A cos A plus cos square A minus 1, and in the denominator I have sine A times cos A. Now, we all know that sine square theta plus cos square theta is 1. So, sine square A plus cos square A would become 1, and that cancels out with the negative 1 over here. Okay. And what am I left with? I am left with 2 sine A times cos A upon sine A times cos A. Now, I can cancel out the sin A's and cos A's from the numerator and denominator, and finally, my answer is just 2, which is what my right hand side is. Okay, next question. This says prove that square root of 1 plus sin A upon 1 minus sin A is equal to sec A plus tan A. Where do I start with? Obviously, the more complex part, which is the left hand side. Okay, so my left hand side is square root of 1 plus sin A upon 1 minus sin A. What do I do with this thing? Okay, so I need to somehow figure it out. I would multiply it with the, I'll basically rationalize it. I'll multiply it with the conjugate. Okay, so it would be 1 plus sin A upon 1 plus sin A. Okay, but all of this has to be inside the root. Okay, the numerator becomes 1 plus sin A times 1 plus sin A, which is 1 plus sin A the whole squared. So 1 plus sin A the whole squared. And the denominator is difference of squares. 1 minus sin A into 1 plus sin A is 1 minus sin square A. So it is A minus B into A plus B, which is A square minus B square. Okay. Now this thing can be written as square root of 1 plus sin A the whole square, and the denominator can be written as cos square A, because 1 minus sin square A is cos square A. Now I can see both the numerator and denominator are squares, and all of this is inside a root. So all the squares and the square roots can neutralize everybody else. So it becomes 1 plus sine A upon cos A. I distribute the denominator, so it becomes 1 upon cos A plus sine A upon cos A. Now 1 upon cos A is sec A and sin A upon cos A is just tan A, and that is exactly what my answer is. Okay, let us move ahead to the next question. This is a similar kind of question. Let's see how to do it. Obviously again I'll start with, or I'll just skip this question for you people. I'll start with the left hand side. Again multiply and divide with the conjugate and then simplify it and you get the answer. It is like a very similar question. You can try this one. Okay, next one. This one says 1 minus cos square A upon 1 plus sin A is equal to sin A. Obviously, I'll be starting with the left hand side. So, the left hand side is 1 minus cos square A upon 1 plus sin A. Can I use any identities? Yes, I can surely use identities. Instead of the cos square, I can write 1 minus sin square. So, it becomes 1 minus. Instead of cos square, it is 1 minus sin square A, and the denominator remains as it is, which is 1 plus sin A. Now, that 1 is actually 1 squared. So, it is actually A square minus B square, which is A plus B into A minus B. So, 1 minus, this thing becomes 1 plus sin A into 1 minus sin A, and the denominator is 1 plus sin A. Now, I can cancel out the 1 plus sin A from the numerator and denominator, and I am left with 1 minus sin A. The brackets are really important because there is a minus sign outside. So, this becomes 1 minus 1, minus and minus is a plus sin A. The plus 1 and the minus 1 just goes away, and finally my answer is just sin A, which is what my right hand side is. Okay, the next question. It says prove that 1 upon sin A plus cos A plus 1 upon sin A minus cos A is equal to all of those things. Obviously, we'll be starting with the left hand side. Okay, so it is 1 upon sin A plus cos A plus 1 upon sin A minus cos A. Okay, there are no powers, so no trigonometric identities, no algebraic identities, but I can surely see fractions and I can simplify these fractions. Okay, so let's cross multiply. Sin A minus cos A into 1 is sin A minus cos A. So sin A minus cos A plus sin A plus cos A into 1 is sin A plus cos A, and in the denominator it is A plus B into A minus B. So this is A plus B and this is A minus B. A plus B into A minus B is A square minus B square. So that would be sin square A minus cos square A. From the numerator, the negative cos A and the positive cos A can just go away, and I'm left with sin A plus sin A, which is 2 sin A, and the denominator stays as it is, which is sin square A minus cos square A. Now if I look at my answer, it is actually 2 sin A, which is there in my numerator, upon something. Now, the question says that I just need the cos in the denominator, I don't need the sin, which means I'll have to get rid of the sin. I have to get rid of this sin square A from the denominator. Now, we all know sin square A is 1 minus cos square A. So, this becomes 2 sin A upon. Instead of sin square A, I'll add 1 minus cos square A minus the existing cos square A. So, finally, this thing becomes 2 sin A upon 1 minus cos square A is minus 2 cos square A, and that is exactly what our right hand side is. Okay, next question. Looks intimidating, but it is actually very, very easy. We'll start with the left hand side, obviously, because again the left hand side is bigger. First step, no powers, so no trigonometric identities or no algebraic identities. We'll have to like cross multiply the fractions. I'm not writing the first step, I'm just cross multiplying it directly. So sin A plus cos A times sin A plus cos A is sin A plus cos A the whole square, plus sin A minus cos A times sin A minus cos A is sin A minus cos A the whole square, and the denominator is again A minus B into A plus B, which can be written as A square, so sin square A, minus B square, so minus cos square A. Okay, in the numerator I can see algebraic identities, which is A plus B the whole square, which is A square plus 2AB plus B square, and the second bracket it is A minus B the whole square. So this thing becomes sin square A plus 2 sin A times cos A plus cos square A plus over here this would be sin square A minus 2 sin A cos A plus cos square A, and the denominator stays exactly how it is. Or I can actually, now since we are very smart, we can try to manipulate it right away. We can see that my answer says that I only need a sign in the denominator, which means I have to plan for getting away with the cos square. Okay, so I'll write the sin square A as it is minus, instead of cos square I'll write 1 minus sin square A. Okay, from the numerator the 2 sin A cos A and the negative 2 sin A cos A can just go away, and we can see sin square A plus cos square A, which becomes 1. Again, there is a sin square A plus cos square A, which also becomes 1. In the denominator, it is sin square A, minus goes inside with both of them. So, minus 1 and plus sin square A. So, 1 plus 1 is just a 2, and the denominator becomes sin square A plus sin square A is 2 sin square A minus the 1, and that is exactly what the right hand side is. Okay. Next question. This one says 1 plus sin A upon cosec A minus cot A minus 1 minus sin A upon cosec A plus cot A is equal to 2 times 1 plus cot A. We'll start with the left hand side. So 1 plus sin A upon cosec A minus cot A minus 1 minus sin A upon cosec A plus cot A. Okay, so the first step is that there are no powers, so no trigonometric identities and no algebraic identities, which means I'll have to look for fractions. Yeah, I surely see fractions, but these fractions are too intimidating for me, because like how will I multiply all of these things and what am I going to do with all of that? You can surely get rid of the fractions, that's not a problem. Probably you can also convert it into sine and cos and then cross multiply the fractions. Whichever way you have to do it, the thing is actually big, like the left hand side is really big and you have to be mindful while doing it. Okay, so let us follow the steps. We will, even though it is intimidating, we will cross multiply it and see. So this is 1 plus sine A times cosec A plus cot A, and then minus, I'll have to put a bracket over here, so 1 minus sine A, and this entire thing gets multiplied over there. So it is cosec A minus cot A, and the denominator gets multiplied with each other. So it is A minus B into A plus B, which is A square minus B square. So cosec square A minus cot square A. Okay, let us open up the brackets. 1 goes with both of them. Okay, so this 1 goes with like both of them in the numerator, the first bracket. So it is cosec A plus cot A. Then the sign goes with both of them. So it is plus sin A into cosec A plus sin A into cot A. That is just the first thing which I have opened up. Now I have a similar second thing. Okay, now I would write it down over here, minus. I have to put up a bracket because that minus would put up an effect on everybody inside. So 1 times all of those things. So it is cosec A minus cot A. Then the minus sin A goes with both of them. So minus sin A times cosec A, and minus sin A times minus cot A is plus sin A into cot A. Okay, now we still have this denominator, but if you see, we have a formula which says cosec square theta is 1 plus cot square theta. Now if I send the cot square theta to the other side, it becomes negative. So cosec square theta minus cot square theta is actually equal to 1. So my denominator is equal to 1. So I can just ignore the denominator for now. Okay, let us now open up the bracket and see what happens over here. So this thing is cosec A plus cot A plus, now sin A into cosec A is actually 1 because cosec A is 1 upon sin A. So this term over here, this term would become 1. So I'll write plus 1. Okay, plus sin A cot A, I'll just keep it as it is for now. So it is sin A times cot A. Now over here, when I open up the bracket, everybody's sign would change because there is a minus sign outside. So it becomes minus cosec A plus the cot A, and then again this sine A cosec A becomes 1 and it is negative and the negative from the outside. So it becomes plus 1 and minus sine A times cot A. Let's see if I can cancel out anything. So cosec A, negative cosec A cancels out. Sine A cot A, negative sine A cot A cancels out. What am I left with? I'm left with 1 plus 1 and cot A plus cot A. So 1 plus 1 is a 2. Cot A plus cot A is 2 cot A. I can factor out a 2 from both of them. So finally, I'll be left with 1 plus cot A, and that is exactly what is my right hand side. You see, this was surely intimidating, really long steps, and you had to be mindful while opening up the brackets. But yeah, it is actually easy, I would say. Okay, then let us come to the last question of this session. This thing says cos theta cot theta upon 1 plus sin theta is equal to cosec theta minus 1. We'll obviously start with the left hand side, which is cos theta times cot theta upon 1 plus sin theta. We've done a similar question in terms of sine, cos, sine and tan, but yeah, we'll do this one. So 1 plus sine theta. First step, we don't have any powers, so no trigonometric identities, no algebraic identities. We only have one fraction, so no fractions multiplication, that just goes away. So the last step, convert everything to sine and cos. So the cos theta is as it is upon the 1 plus sine theta as it is. The cot theta can be written as cos theta upon sine theta. In the numerator, cos theta times cos theta is cos square theta, and the denominator they get multiplied. I won't multiply it, I'll write it in a bracket. So 1 plus sine theta times sine theta. Again, in the numerator, the cos square theta can be written as 1 minus sine square theta, and the denominator still stays the way it is. So 1 plus sine theta times sine theta. Now this is actually 1 square and it is difference of squares. A square minus b square is a plus b into a minus b. So 1 plus sine theta into 1 minus sine theta, and the denominator is 1 plus sine theta times the sine theta. Okay, I can cancel out 1 plus sine theta from both the numerator and the denominator. So I'll be left with 1 minus sine theta upon sine theta. Distributing the denominator, it becomes 1 upon sine theta minus sine theta upon sine theta. So 1 upon sine theta is cosec theta minus sine theta upon sine theta is just 1, and that is what my RHS is. Okay. These are all the questions. In the third episode, we will be doing even more proving questions and similar kind of questions, but that would be a little bit on a higher level. So just make sure that you practice these questions on your own. Again, just to remind you, the notes of whatever we are doing in the videos are in the description. All of these questions in a worksheet format are again in the description in a PDF format. So you download that, solve it for yourself, and then move ahead to the next episode. Okay, thank you so much. Bye bye.